Hello all, let us start with Unit 5 and the topic what we are going to discuss today is generative adversarial networks and its architecture. Before moving on to this topic, let us have a quick look on the topics of Unit 5. In the first part, we will be talking about GAN, its architecture, different evaluation parameters and few of its applications. In the second part, we will talk about deep dream and neural network style of transferring data. Coming to GAN, these are a new type of neural architectures introduced by Goodfellow and other researchers at the University of Montreal, including Yoshua Bengio in 2014. I can define a generative adversarial network as the capacity to create hyper-realistic images, that is fake images or fake videos or fake music and fake text, any kind that will be same as that of the original data. That can be understood by looking into the figure here. Except the right column in both the images, none of the images of the digits and none of the faces shown here are real. All are fake data. But the right side represents the original numbers and the original faces. What does this mean? This shows that the ability of a generative adversarial network is to learn these features during the training process, imagine its own new image and generate a new image patterns that it has learned during the training pattern. Coming to the architecture, it is based on adversarial training. Now, what do you mean by adversarial? It involves the opposition or it involves the opponents where one tries to compete with the other. Hence, it consists of two opponents here. One generator which will generate fake data, which will represent a replica of the original data, and a discriminator will try to predict whether the data which is generated by a generator is fake or real. Let us understand the analogy of adversarial network here. That is nothing but generative adversarial network. To the left side you can see you have counterfeiters which represents generators in a GAN. What will they do? They will try to create fake amount or fake money which will be a replica of the original money. That will be, it will look as real as possible. And the main goal of this counterfeiter is to fool the policeman. Now, what is this policeman? It represents discriminator model in a GAN. What will they do? They will analyze the money to determine if they are real or fake. The goal of discriminator is to distinguish between real and fake. The goal of generator is to fool the discriminator. The generator will try to fool by improving the quality of the fake data, and the discriminator will improve its detection skills to catch the fake data. In this adversarial process, both the generator and discriminator are trying to improve themselves iteratively. So this is the architecture which represents two opponents here. One is generator and the other is discriminator. And what do you notice here is in the generator, it represents a inverted convolutional network where you have first starting with a flattened vector and then you have convolutional layers with increased number of height and width. Anyways, we will talk about this generator in the next slide. How is this operation in the architecture? The generator will take some random numbers and generate an image. A fake image will be generated because it got learnt with the parameters that are being trained to generator here. This fake image along with some real images of the dataset will be given as input to a discriminator. Then discriminator will classify it to be as real or fake. At the discriminator you will have a dense layer following a sigmoid activation function as we are performing here binary classification. It will generate the numbers between 0 and 1 where 0 represents fake data and 1 represents real data. This is the architecture of generative adversarial networks. Coming to the next topic called as deep convolutional GANs. As I told, GAN was introduced in 2015 using a multi-layer perceptron model, but to improve the accuracy of the generator and the enhance discriminator, convolutional layers were used to build these GANs. Hence, those GANs which were built in 2016 to increase the accuracy were called as DC GANs, that is deep convolutional GANs. Replacing multi-layer perceptrons with the convolutional layers, GAN got replaced with DC GAN in 2016 by a scientist called as Alec Radford. So it has the same models, the generator model and the discriminator model. Let us start with the discriminator model first. Discriminator model will be provided with two kind of images, the real images of the data set and the fake images that are coming from a generator. So what will this discriminator do? It will predict whether an image is real or fake. How will it do that? It will make use of stacked convolutional layers followed by dense layer, output layer, and in the output you will have a sigmoid activation function because the output is a binary classification. Training this discriminator model is a straightforward process because we will be feeding real image from the dataset as well as the fake images coming from a generator, and training these model based on these features, it will try to classify whether the given image is fake or real. Hence, the training of a discriminator is a straightforward process. Let us implement this discriminator on Keras and then move on to the generator model. This is the snippet of implementing a discriminator in Keras. You will be defining a discriminator model, and a sequential model will be stored in an object called as discriminator. You will have convolutional layers with 32 neurons, and anyways all these commands are not new to you. You'll talk about leaky ReLU activation function here. You will stack dropout layers, convolutional layers, zero padding, batch normalization, dropout, everything, and you will have a model summary. In model summary, what do you notice is you can see that the discriminator model follows the regular pattern of a regular convolutional neural network, because we will be stacking all the convolutional layers, batch normalization, activation function, dropout layer to create our model. And what do you notice here is the height and width are reducing and the depth is increasing, which will happen in a traditional convolutional neural network. Coming to the generator model. So what will a generator model generate? It will generate fake data that represents replica of the original image. So the generator model will take some random noise or random data and will try to mimic the training data set to generate fake images here. The goal of generator, as I told you, is to fool a discriminator by trying to generate images that are perfect replicas of the training data set. Now, as the training is continuing, it will get better and better after each iteration. But remember that the discriminator also is getting trained at the same time along with the generator. Hence, the generator model will look like the generator model will try to improve itself as the training process continues. And what do you notice here? It is an inversion of an inverted convolutional neural network, where you have an input vector with some random noise. And this is an input vector with random noise. Reshaping is done, and then you will get an output of 7,7,128, increasing the dimension by increasing the number of convolutional layers, and finally a fake image will be generated. Now, in a convolutional neural networks, to increase the to reduce the dimensions of the image, we will be making use of max pooling. But here, as in a generator, what we are doing is we are increasing the height and width, that is increasing the dimensions. So for that purpose, we will be performing an upsampling. This is an example. You can see here, this is an input image. When upsampling is of scaling size 2,2, each number will be repeated 2 along the row and height 1, 1, 1, 1. Similarly with this 2, 3 and 4, and this is for scaling size 3, 3. So upsampling is performed in a generator to increase the height and width of the image. This is how it is implemented in Keras. Everything is same here. You will be defining a generator model and storing that sequential model into a object called as generator. The rest all is same. The only thing what you add up here is an upsampling 2D to increase or to scale the image dimensions. This command will be used. And this is the model summary. And what do you notice here is, initially you have a one-dimensional vector. This got reshaped to 7,7,128. Upsampling with 2 by 2. So hence 14,14,128 and so on. So this is the model summary, what is being generated. Now that we have studied about generator and discriminator and how the operation block diagram also we have seen, let us put both the operations together in training process. So the training involves training of a GAN will involve two processes. One is training the discriminator. Obviously, as we are having two opponents, two training processes will be carried out, and the second is training the generator. In training the discriminator, what do we do? As I told, it is a straightforward process. Why? Because that will be trained with labeled images coming from the generator as well as the real images that are taken from the dataset. So it will classify between the real and fake images with a sigmoid prediction. Coming to training with the generator, this process is very tricky because the generator model cannot be trained alone like a discriminator. It needs the discriminator model to tell whether it did a good job of faking images or not. So for that, we will be having a combined network here when we are training a generator. As shown to the right side, this is the training part of your discriminator, where labeled images of real and fake data are provided, and it will classify fake or real using a sigmoid activation function. Whereas in a generator, you have random input, noisy vector is fed to a generator. Generator will generate a fake image which is fed to a discriminator. And what do you notice here is the weights of the discriminator are freezed here. Though the weights are freezed, still this discriminator will perform the binary classification, and the output is fed to the generator. Based on the output, this generator will update the weights. And what kind of feedback it will get? How well the fake data has fooled the discriminator. Based on this feedback, which will tell generator how well generator has fooled the discriminator, it will update its weights and then generates the fake data after every epoch. So during generator training, the goal is to minimize the ability of a discriminator to distinguish between real and fake data. Hope you have understood the training process of both discriminator and the generator. This is how training is performed in Keras. This is the combined model of generator, where generator and discriminator, here weights are frozen, and this generator will update the weights based on the output which is being fed to the generator from a discriminator. And this is the snippet for performing the training operation of a generator. And we will be making use of compile the model using binary cross entropy and Adam as an optimizer. And finally, you notice here is, as the number of epochs are increasing, the originality of the data is also increasing. That is, the generator is performing well as it is getting trained. So epoch 0 starts with random noise, and at the end you have a perfect image that is being generated. That is, a generator will get better and better during the training process. Coming to the next topic called as GAN minimax function. Now what is this minimax function is? It is a zero-sum game. Why do you call it as a zero-sum game? Means you will be providing scores to two players. An increase in one player's score will result a decrease in the second player's score. This in artificial intelligence is called as minimax game theory. It is one of the decision-making algorithm which is used in two-player games. Why do we call it as a two-player game? Because you have a generator and a discriminator which are trying to oppose one another. So this is the equation where GAN will be trying to optimize the loss function, overall loss function called as V of D comma G. So this first part represents the discriminator output for real data, and this represents the discriminator output for the generated fake data. And the goal of discriminator is to maximize the probability of getting correct label, and the goal of generator on the other hand is to minimize the chances of getting caught. Here D of X represents the probability that X is real, and the goal of discriminator is to maximize this D of X value. And here G of Z represents fake data generated by G, that is generator, and G of Z represents that the discriminator thinks G of Z is real. Now what do you note here is, discriminator will try to maximize the overall function V of D comma G, and a generator will try to minimize this overall function V of D comma G by generating G of Z, which is the output of a generator which will fool the discriminator. So this is nothing but called as a minimax game theory, which will be played among two players. The maximizer player tries to get the highest score possible, while the minimizer player tries to do the opposite and get the lowest score possible. These are the terms which are used in the equation. The discriminator takes its input from two sources. One source is from the generator output and the other is the real training data. So generator output is represented as G of Z and the real training data is X. D of G of Z represents what? The discriminator output from the generator, which is denoted as D of G of Z. Once again, the entire equation. So the discriminator and the generator will try to increase and decrease this overall function V of D comma G by finding the error from the discriminator and error from the combined model training. In the next class, we will talk about the metrics which are used to evaluate this GAN and few of its applications. Thank you all.